In Uganda, innovative solar drying technology is transforming post-harvest handling and adding value to agricultural produce. We showcase the experiences and impacts of this emerging productive use of energy. Supported by the Sustainable Energy for Smallholder Farmers project, one of Energizing Development's multi-country initiatives, this endeavor is making significant strides in transforming the agricultural landscape.
Singa teyali kiri ku biseera ebyo nali sirina pulaani esomesa mwana wange. Ate si kyokka ne savinga mu kiri omwo bagenda okugula akabokisi nga nfunamu 5 nga bwayengedde munoga ne mutwala owa kifuutuko mu dryer.
Smallholder farmers in Uganda face over 20% post-harvest losses, especially the horticultural farmers, where you find a lot of oversupply of produce in the market. This usually results into prices of produce going down. Through these dryers, we actually were able to establish different demonstration sites.
When we were selling in a dry form, we could have a compromised quality of the chili just because we were drying it from the open sun. It could take us not less than 12 days to dry a batch of chili. Then we could also face a lot of challenges with the safety, health problems when handling the chili. When we go ahead to grind into powder and make chili oil, out of a kilogram, we can make between 60 and 80,000 shillings that we used to which used to fetch only 2,000.
The dryers were designed and installed by Solar Nation Limited, and also we had the Intellisys Uganda Limited supporting us in development and installation of remote monitoring systems, as well as the dryer control system.
The solar dryers that we installed in Uganda are called biothermal solar tunnel dryers. It's a hyperbola dome shaped, so we call it a tunnel. When you enter in there, the heating area where we are placing the trays. So that's why we are calling it a solar tunnel. And we call them biothermal because they're not only relying on the sun, because we have a hybrid. We hybridize them by making sure that we extend their capacity to dry. In times of high levels of humidity and low sunshine, we are still able to dry.
Remote monitoring helps because this enables a farmer who is not even on the site to know the temperature, to know the humidity, and with the time they will even be able to know that their crops or whatever it is they are drying has reached optimal drying moisture content. But if they do not have access to an internet connected device, the system still sends them at the end of the day a simple report showing them the average drying conditions of whatever they had put within the dryer.
We played our role as a ministry, give technical support, project site identification, design of the project, and full implementation of the project. All the support to have this project a success.
There actually exists viable business cases for scaling and adoption for solar drying at various levels, say aggregators, farmers, etc. But for this, there has to be a number of aspects in place. One is the access to premium markets. So using MRIC as an example, once the chili is dried, the chili oil is made, the business case is even more viable if there is access to a premium market for the chili oil. And part of this includes, for example, having a Q mark from UNBS. There's need for access to high-level quality inputs. Now in this case, that would be high-level chili, so that as this is dried, the product that we are adding value to also has a significant market. There's also need for continuous research to have this coming in as the core of optimization of the drying process and the utilization of the dryers. And finally, on the enabling environment side, there's need for critical aspects such as access to infrastructure like roads that can help these products, get to the end market.